Everyone thinks a battery is a battery, but a flow battery charges 20,000 times, while lithium quietly dies at 4,000. That gap is the whole story, so let's open the box and see exactly why. Here's the problem forcing this. AI data centers are pulling power in huge, hours-long surges. The grid now needs storage measured in hours, not minutes. Lithium can do it, but it fades after about 4,000 charges, so you replace whole banks every few years. At grid scale, that's brutally expensive. So the winner isn't decided by capacity alone. It's decided by cycle life and how long each charge lasts. Start with the shape of the thing. A flow battery has two big tanks of liquid and one central stack where they meet. Picture two water tanks feeding a single faucet in the middle. The liquid is the energy. The stack is the power. Here's the part that changes everything. Those two jobs are separated. In a lithium cell, the energy and the power are locked together inside one sealed can. The same material that holds the charge also has to deliver it. Grow one and you're stuck with the other. A flow battery splits them apart. Want more energy? Add more liquid to the tanks. Want more power at once? Make the stack bigger. Neither choice touches the other. That single design move, pulling storage out of the cell and into a tank, is why this battery ages so differently. The liquid that holds the charge never gets torn apart, because holding charge and delivering it are two separate places now. Lithium can't do that. Its storage and its muscle share one crowded room, and every cycle wears that room down. So a flow battery isn't a better version of lithium. It's a different machine. But splitting energy from power is only half the trick. The real magic is in the chemistry. Now the chemistry, and it's simpler than it sounds. The liquid is water with one metal dissolved in it, vanadium. Vanadium is unusual. The same metal can carry different amounts of electric charge, like the same coin flipped to different faces. One tank holds the low-charge version. The other holds the high-charge version. Between them sits a thin sheet called a membrane. It's a doorway that only lets tiny charged particles slip across while keeping the two liquids from mixing. Here's how a charge happens. Pumps push both liquids through the stack past that membrane. Feeding in electricity forces vanadium on one side to grab electrons and the other side to give them up. The liquids come out changed, now storing energy. That's charging. Discharging just runs it backward. The vanadium hands the electrons back, and those electrons don't cross the membrane. They're pushed out through wires, through your data center, your grid, your lights, and that moving stream of electrons is the electricity doing work. The membrane handles the small stuff inside. The wires carry the power outside. Charge pushes the reaction one way. Discharge lets it fall back. Same liquid, same metal, endlessly rocking between two states. And that sameness is the secret to the 20,000 number. So why 20,000 charges with almost no fade? It comes down to that one repeated word, same. Both tanks hold the same metal, vanadium on both sides. When a little liquid seeps across the membrane over the years, nothing is poisoned. It's the same stuff meeting the same stuff. In most batteries, the two sides are different chemicals, and every leak slowly contaminates the whole. Here, there's nothing to contaminate. That's the first reason. The second is even bigger. In lithium, the charge is stored in a solid, a rigid crystal lattice like a tiny brick wall. Every charge jams particles into that wall, and every discharge yanks them out. Do that a few thousand times, and the wall crumbles. That crumbling is the fade. A flow battery stores its charge in a liquid, and liquid has no wall to crack. You can flip its charge state forever, and the liquid simply doesn't wear out. When performance does drift, you don't scrap anything. You rebalance the liquid and it's fresh again. The only part that genuinely ages is the stack, and the stack is the one piece built to be swapped. Tanks of liquid that never degrade, a rebuildable core. That's where 20,000 cycles comes from. But long life is useless if you can't make it big. Here's where the shape pays off. Because energy lives in the tanks, you stretch how long a flow battery runs simply by building bigger tanks and mixing more liquid. The stack, the expensive, powerful part, stays the same size. That's why these are aimed at 4 to 12-hour storage, exactly the long, steady stretch a data center needs overnight. But there's a real cost. That liquid is heavy and takes up a lot of room for the energy it holds. Pound for pound, lithium packs far more into far less space. Up front, a flow battery also costs more per unit of storage. According to industry estimates, installed prices run higher per kilowatt-hour than lithium today. So you will never see this in a car. The tanks alone would fill the trunk. It only makes sense bolted to the ground, feeding a grid or a data center that runs for decades. That's the trade: give up compactness and a lower sticker price, and in return get something that runs for hours, costs almost nothing per cycle, and lasts a generation. For a phone, that's a terrible deal. For a warehouse of servers that never sleeps, it's close to perfect. Which finally settles the number we opened with. So back to the opening maths. A flow battery charges 20,000 times. Lithium fades at 4,000. That's roughly 5 times the working life from one install. Now stretch it over a real grid asset, 20 years of daily cycling. In that window, a lithium bank gets used up and replaced several times over. The flow battery just keeps running on the same liquid. Yes, it costs more the day you install it, but you buy it once and it outlives 3 or 4 rounds of lithium doing the same job. Spread across 2 decades, the pricier battery quietly becomes the cheaper one. That's the whole reason flow batteries are being built for long-duration grid and AI storage, even while lithium still rules phones and cars. Different jobs, different winners. Lithium wins where space and sticker price matter most. Flow wins where the clock runs for decades, which is exactly the job the AI power crunch just created. One line to keep: split the energy into liquid tanks, use one metal on both sides, and a battery can run 20,000 cycles with almost no fade. Next question worth opening: if flow batteries last this long, why doesn't the grid run entirely on them? That's a story about cost and factories, and it's the one we'll open next.